Good morning, guys. Good morning. Can you hear me?
Yes, miss.
All right.
Yes.
Perfect. Okay, those are the people who woke up early. Good morning. Where are the rest? Are they?
We do not know.
So I think they're still asleep.
I'm going to send them messages on WhatsApp
All right.
to see if they come.
Okay.
I woke up 8:45.
Really? I don't care. As long as you're here in the session, thank you so much for caring. It doesn't matter whether you woke up even 8:55. It doesn't matter. As long as you're here to attend the session, it's fine with me. All right. So I will take the attendance now. It's 27th, right? Yes, it is the 27th. Okay. Abdel Halim, I cannot see him. Adham is here. Ahmed Ahmed is not here. Ahmed Haytham, no. Ali is here. Amr is not here. Hamza is here. Julie is here. Judy, not here. Lena, not here. Mira is here. Nancy is here. Ruqayya is here. Celine is here. Yusuf Saygid is not here. All right, guys. So we are going to start with homework correction first. And then after that, we are going to finish the remaining worksheets. And this is it. We will be done with our book. We have 2 pages of the reading homeworks. We will be doing them next week with the revision. I have the answers for them. I will just give you some time to think about it before I start answering it with you. Those reading homeworks, that was pages 37. I will not consider them a homework. I will consider them a classwork that we will do next week during the revision. So it was the pages I'm talking about are pages 37 and page 93. Okay, those are the pages that we are going to do next week during the revision sessions, along with, of course, the revision sheet at the end of the book, which starts at page 96. You will have some pages that you will write written home activity on them. Pages 94 and 95. Have you seen them? And also pages 38 and 39. Those were supposed to be experiments that we can do at school, or if you would like to do it at your home, you're more than welcome. If you have the wanted materials, if you have the needed materials, you can do it at your home. So you're more than welcome to try. So some people just joined us, Yusuf and Ahmed Ahmed, right? Ahmed Ahmed and Yusuf Saygid. How was the quiz?
Easy.
Did you like it?
It was really easy.
I got 11 out of 11.
This is the your quiz plus the bonus question. So you got 10 out of 10 plus one bonus mark. Okay.
I also got 11 out of 11.
What? Yeah,
I also
I don't
got
know.
the bonus
Check
question.
model. You got the bonus question, but I don't think you got the full mark in the quiz, Ali. I want you to check, please. And yeah, by the
Yes,
way,
I checked the questions and they were all correct.
I'm not quite sure, Ali. I think you had something wrong. I will check again and tell you next week. The thing is, yes, one of the things that we will do also next week, along with all this revision sheet solving and everything, because we have like 5 sessions next week, 4 during the session during the week and 1 right before the exam, if I remember correctly. We are also going to go through the 2 quizzes that we took during this trimester, quiz 1 and quiz 2. I'm going to solve them with you again, so that you know your mistakes and you are fully prepared to get into the exam. The exam, of course, is going to be super easy. Don't worry about that. I'm not going to bring some complicated questions for you, so I don't want you to worry. All right. Okay, let's start now with the homework correction. I want you to open your resource packs, please. Pages 87, page 87 first. So let's start together. Page 87.
Miss, we didn't do 85.
We didn't do 85. Was it a homework? It wasn't a homework.
No.
I told you that we're
No.
going to finish correcting the homework and then we will answer the rest of the pages. We did not do 85 and 86 and 91 and 92. I know. Okay. So now I want you to open page 87 first. It says the diagram below shows 3 trolleys. Peter put a bar magnet on each trolley. Magnet B attracted magnet A and magnet B repelled magnet C. Okay, so again, magnet B attracted magnet A and magnet B repelled magnet C. On the diagram above, label the north and south poles of magnets A and C. Anyone want to answer this? Anyone would like to answer this one? Raise your hand, please, if you want to answer this one. I want you to label the magnets. Come on, guys. Easy one. Yes. Ahmed Ahmed raised his hand. Hamza raised his hand. Nancy raised her hand. And Mira, yes, I was looking for Mira. Mira raises her hand before the session even starts. Right? Right, Mira?
Yes.
You raise your hand before the session even starts. Okay, so Mira, yes, I want you to do this, please.
Okay.
B and A are attracting each other. So what do you think will be the pole facing the North Pole of B?
South.
South, yes. So the other side will be, of course,
North.
north. And what about B and C? They are repelling each other.
I would write here north.
Where? Here or here? What will be facing the south?
Yes. North here, like
Facing the south. If I wrote north here, then they will attract.
here. No, not here.
Here?
Here's Yeah, no, yes, north here.
Yes, okay. North will be here, so here will be south.
South.
All right, thank you, Mir. So this way, B and A will be attracting and B and C will be repelling, okay? All right, so let's go to the next question.
Yes,
Yes,
I just joined, so I don't know what page you are.
this is the page 87. Look at Judy, she's all, still waking up and everything. This is page 87, dear. Are you awake? Did you have breakfast?
Yes.
Okay, very good. So Judy is here. And did anyone else join recently? I'm just checking for the attendance. No, no one else. Okay. Ali, Peter turned trolley B around. Trolleys A and C were not turned around. What would happen now when Peter pushed them all together? Use either attract or repel to complete each sentence below. So he turned only B around. Okay, let me just remind everyone, how did we label the rest? So the rest.
They're going to be the same way. They're going to look the exact same way.
Yes, yes. So this is going to be the south and this is going to be north. So yes, Ali, what will happen now? Magnet B would do what to
Magnet B would repel magnet A, magnet B would attract magnet C.
Thank you, Ali. All right. Okay, guys. Now let's go to page 88. Let's go to page 88. In page 88, Peter held two trolleys close together and then let go. The magnets repelled each other. Draw an arrow on both magnets to show which way they would move. I will do this. They just want us to see whether we understand the word repel or not. So this is why they're asking us to draw the arrows showing how will each of those trolleys move. So they are repelling each other. So of course, the arrows will be opposite to each other. Okay. Now the next question is, Peter took a magnet, a steel bar, and an aluminum bar. He put them on 3 trolleys as shown below. What happens to the steel bar as he moves it closer to the magnet? Ahmed Ahmed.
It will attract.
Yes, the steel bar will get attracted to the magnet. The steel bar will get attracted to the magnet. I will ask you a question, guys. I want you to pay attention to the question I'm going to ask right now. And please focus, okay? Now I have a steel bar and a magnet, all right? As Ahmed said, the steel bar is going to get attracted to the magnet. So whether the north side is facing the steel bar or the south side facing the steel bar, in both cases, will the steel bar get attracted to the magnet? Does it matter what pole is the magnet on? Yes, Ahmed. Very good, Mira. Yes, and Ahmed, you were going to say the same? Yes, it doesn't matter, okay? As long as there is a magnetic material next to the magnet, whether this magnet is facing the magnetic material from the North Pole or the South Pole, it doesn't matter. Either way, the magnetic material will be attracted to it. The only time we think about attracting and repelling is when 2 magnets are facing each other. This is the only case that we look at the poles, and this is the only case that sometimes magnets will repel each other. But magnet will never repel a magnetic material. Magnets will never repel a steel bar or an iron bar. it will never repel a magnetic material. It will only repel a magnet that is facing the same pole as it is. Okay, Ahmed, do the second one too, please. What happens to the aluminum bar as he moves it closer to the magnet?
Also, it will repel.
No. I was just saying it will not repel. I know that it will not attract, but that doesn't mean it will repel. Okay, because the aluminum bar is not a magnetic material. Okay, aluminum bar is not a magnetic material. It's not steel or iron or cobalt or nickel, so it will not be attracted to the magnet. But that doesn't mean it is going to repel. Okay, because if it's repelling, this means that this is a magnet too. The aluminum bar is a magnet, and it's not. Okay, the aluminum bar will simply not get attracted to the magnet. It's like you're putting a glass of water next to the magnet. Will it repel? It will not repel. It will just stay there. Okay, if you put a ball next to the magnet, it will not repel. If you put anything that is non-magnetic next to a magnet, it will just not get attracted to it. It will just be there, stay there, but it will never repel. Repel is actually a force. You can feel the magnet pushing away the other magnet if they are repelling from each other. But in other non-magnetic materials, they will just won't react. They will not react against the magnet. Do you get it, Ahmed? All right. So I will write, it will not get attracted to the magnet. Okay, now we will open page 89. Are you done, guys? Should I erase?
Yes.
Okay. Page 89. Liam has a toy train with 2 carriages. Lina, did you join us?
Yes.
All right. Liam has a toy train with 2 carriages. It has bar magnets to join the carriages to the engine as shown below. So right here, we want to write north and south. All of the carriages are attracted to the engine. So we don't have any repelling problem. So we want to know how will the poles be distributed. Okay, so I'm going to ask Hamza to answer this one.
Okay, Miss.
The
second one's going to be south.
Yes, south.
Then north.
Then north. What about this one too?
Then south, north.
South again and north again. This way, all of them will be attracting each other. Thank you, Hamza. All right. So the next question is, Nisha moves. Let me just go down a little bit. Nisha moves a different bar magnet towards the magnet on the engine. The magnets do not touch each other. The engine moves away from Nisha's magnet. All right. Explain why the train engine moves away from the bar magnet. Nancy, can you answer this? Nancy, are you there?
Yes, Miss, can you hear me?
Yes, I can hear you now, dear. What happened here? Why is the engine moving away from the magnet?
Okay. Because the similar poles repel.
Yes, very good. So this means that the engine and Nisha's magnet are facing each other from the same pole. Okay, so the similar poles of both magnets are facing each other, so they are repelling from each other. Okay, so I'm going to write because the similar poles are of the magnets are facing each other so they will repel. Okay. All right, now the last page of your homework, page 90.
Miss, I did not finish yet.
Okay, finish quickly, please, Judy. Did you do the homework?
Yes, I did it all, but this page I did not understand it.
Do you now?
What?
Do you understand it now?
Yes.
ماشي. Are you done, Judy? We need to flip the page.
Yes.
Okay. Now let's go to page 90. In page 90, we have Ali and Jane. Ali and Jane describe their ideas about metals. Here, Ali is saying all metals are magnetic, and Jane is saying only some metals are magnetic. Jane recorded some observations from their investigation in a table. Does each observation support their ideas? Tick one box on each row of the table. So the first one, which says the iron nail is attracted to the magnet. This supports whose idea? Ali and Jane's or only Jane's? Ruqayya, are you there?
Yes.
Okay, can you answer this one?
Okay.
The iron nail is attracted to the magnets. Does this support Ali and Jane's ideas? Or it supports only Jane's idea, or it doesn't support any of their ideas?
It supports Ali and Jean's idea.
Yes, it supports both of their ideas because iron nail is a metal, so both of them could be correct. All right, what about the next one? Continue, Ruqay. The steel clip is attracted to the magnet. It also supports both of them. Now, let's see the next one. The metal coin is not attracted to the magnet. This supports whose idea?
Jane's.
Jane's idea. Excellent. Now, the next two, the modeling clay is not attracted to the magnet. This supports who? Does it support any of their ideas?
No.
No, so it does not support either idea because modeling clay is not a metal. So they are not talking about non-metal stuff. They are only talking about metal stuff. So this doesn't support any of their opinions. And the next one, the chocolate is not attracted to the magnet. Is the chocolate a metal? No one also. Yes, very good, Ruqayya. Thank you so much. All right, we are left with the last question. We are left with the last question, which says, Ali said to improve our test, we should have measured how far each material moved when it was attracted to the magnet. Jane said this would not improve our test. Why was Jane right to think this would not improve their test? Adham, can you tell me?
Yes, miss.
Yes. So why do you think Jane is right?
Because it will not help them to know if all metals are magnetic or only some are magnetic.
Very good. Thank you so much, Adham. They are not testing, thank you, Adham. They are not testing the strength of a magnet. if they are testing the strength of a magnet, they would see with how what is the distance that this magnet moved or this material moved to the magnet, but they are not testing the strength of the magnet. They are testing whether all metals get attracted to a magnet or only some of them. Okay, thank you, Adha. Okay, so the answer is oh, what happened? Okay. Here we go. All right, so right here, I'm going to write that it will not help them to know whether all metals are attracted to magnets or only some of them. Okay, this is it.
Miss, I have a magnet.
Who? Ruqayya?
Ruqayya.
Yeah. Really?
It's red and green.
You have a magnet what?
It's red and green.
It's red and green. Okay,
Yeah.
interesting. I have a lot of magnets hanging on my refrigerator. I love to collect them
Me
from
too.
different places that I travel to. So I keep
also
collecting
have.
them. Yes.
Me too. My mom does that all of the time.
Yes, they are a very good souvenir, actually. It reminds you of the trip and everything. So
Yeah.
I like it.
My mom got one from Venice and Rome.
Your mom what?
My mom got one from Italy and Rome.
Oh, nice. Interesting. Okay. So now we are going to complete the classwork, guys. The classwork, we're going to start with page 85. Okay, I think we're done from page 75 to 84. We already did them, right? So now we're going to do page 85. So I want you to open page 85. Okay. This is page 85. Question number 1 says, a clown is making some rings float in the air. The lowest magnet that has its north-seeking pole upwards. It means that, yeah, it's already written here that this magnet, the last one, the north pole is upwards and the south pole is downwards. Please mute your mics. As shown in the diagram, show the arrangement of the poles on the magnets needed for this to happen. We need to do some floating magnet trick, okay? Salim, can you tell me how will I write each of the poles? Salim, are you there? Okay, Ahmed Hatem, are you there?
Yes.
Okay, I want you to tell me how should I write the poles?
Okay.
I want them to float, so they are supposed to be repelling from each other. Hey. This is the south and this is the north of the last one. What about the upper one?
Yes.
Yeah. We want them to repel, Ahmed.
Okay.
So what should be facing this one?
North.
North also, yes. So this should be south. Okay, what about this one?
South.
South. So this should be north. Thank you, Ahmed. Okay. Do you understand, guys, the rest of you?
Yeah.
Okay. I'm going to erase this and do question number 2. In question 2, it says, Sarah found her little brother playing with magnets. He was banging them together. Write a safe handling rule. Write a safe handling rule that Sarah should tell her little brother. Hey, who would like to answer this one? Ali, can you tell me? What should Sarah tell her little brother?
Sarah should tell her little brother not to bang magnets together because they can make
The small pieces, what?
the small pieces might come in his eye.
Exactly.
Or his,
Yes, it might fly and get into his eye. Okay, so he should stop banging them together because small pieces may fly and get into his eyes. Ali, I want you to do the next one too. Small pieces. Okay. Sarah's mother asked her to store the magnets away. What do you advise, Sarah? I just need one advice for the
I
storage.
advise her to listen to her mom.
Oh, yeah? And what should her mom tell her? Give me some extra thing.
Her mom should also tell her
Yes.
that she should not even have magnets in the first place.
All right.
Because her brother's just gonna
Ali
take
will be a very strict dad. So I would tell Sarah not to put the magnets in wet or humid places. Why? Because water will make the magnet lose its magnetic force. Okay. All right. After finishing, we're going to do page 86, and we still have 2 pages to go, so we need to hurry up. Okay, we still have like 4 minutes left, so we need to hurry up. Okay, are you done? Should I erase?
Yes.
Okay.
No.
Adham, I already did it. I'm sorry. Can you rewatch the video? I'm going to upload it after the session. You can rewatch it and write the answers. All right? Question 3. Theo, this is page 86. Theo is at a recycling center. He sees 5 containers with contents that need separating. Now, this is something, guys, that you're going to learn next year and the year after. How to separate different mixtures from each other. This is really fun. And if you're lucky enough and you are in the school, you will be able to do it yourself in the lab. Okay? We use different materials to separate different types of mixtures. So now, take 3 containers with contents that can be separated with a magnet. Okay, who can answer this? Julie, are you there?
Yes.
Yes. What can I use a magnet in to separate the 2 mixtures from each other, or the 2 components from each other? Aluminum cans and paper. Can I use magnet here? Will any of them get attracted to a magnet?
No.
No. Okay, so this is useless. What about the next one? Steel cans and plastic bottles. Can we separate any of them using a magnet?
No.
Yes, steel cans. Steel is one of the magnetic materials, so they will be attracted to the magnet.
The magnets.
Yes. What about this one? Glass jars and steel lids.
Yes.
Yes, this also is going to be separated using a magnet. Plastic bottles and paper?
No.
No. Iron nails and copper nails?
No.
Yes, iron nails will be attracted to the magnet while copper nails will not be attracted to the magnet. Okay, so iron nails, iron, steel, cobalt, nickel are the magnetic materials that will be attracted to magnets. All right, guys, we don't have time to do 91 and 92, so we will do it next week, okay? We will do it. I will not give you a homework today. Or will you, do you like to take it as a homework?
No.
91 and 92? They're
Yeah.
really,
No.
No.
they are really
No.
easy.
No.
Okay,
No.
all right,
No.
all right. Have a nice weekend, guys. Bye-bye.
Bye.
Bye. Bye.